Guys, this is a new video for differential equation. Now in this video I will talk about the formation of differential equations. So it is all about arbitrary constants. So if you can replace kind of arbitrary constant, then it's okay, you can form a differential equation. So what are the arbitrary constant? Actually, arbitrary constant are kind of constant where we can say like the constant are, the constants are not fixed. Actually, they are variable constants. Like for a particular case they are fixed. Like, let me introduce you with a kind of, let's say this is the equation of parabola, right? This is the equation of parabola. Now in that case, this a is the arbitrary constant. Why this a is the arbitrary constant? Because for a particular parabola the value of a is fixed. Let's say this is y square equals to x. In that case we can say the value of a is what, 1 by 4, right? So however, hopefully you can understand what are the arbitrary constant, what are the sense. Now in that video I will talk about the differential equation of straight line, of a circle, of a parabola and hyperbola. So first of all, it is all about replacing the arbitrary constant. If you can replace, then you can easily find out the differential equation. Point to be noted, if we can replace, then we can replace, if we can, then we can generate. That doesn't mean, actually I want to say something like, if you can replace, then replace it. You will get a perfect, actually you will get a kind of perfect differential equation after replacing the arbitrary constant. So however, in that case, first, so step by step, let me proceed with particular procedure. So first of all, this is the equation of a parabola. So let me talk about first what we are talking about. Parabola, right? We are talking about parabola. So basically, in that case y square equals to 4ax. So basically for replacing a, we can differentiate it a single time. Let's say this is the differentiation of y, actually y square with respect to x. This will be 2y into dy by dx, right? Wait a moment. So this is dy by dx is equals to 4a, differentiation of x with respect to x is 1, right? So this will be something like that. Now this is a. Now we have to replace a. In some of the cases you will see, after differentiating dependent variable or independent variable, doesn't matter, you will get like the constant will become 0 actually after differentiation, because differentiation of a constant is 0. But in some of the cases you will face the constant will not, like, uh, will not become 0 actually. So in that case you have to replace a. From the primary equation you can say that the value of a is what, this is y square by 4x, right? So this is the value of a. So we can say that 4 into y square by 4x, very nice, into 1 by 2y. I am taking the 2y here actually. So dy divided by dx, not actually, it is ddx of y, actually not divided by, it's a wrong statement. However, in that case, 4 will be cancelled out, this y and this square will be cancelled out, and we will get something like, this is the differential equation, dy by dx is equals to y by 2x. This is the differential equation for, what the hell is that? This is the differential equation for parabola, where the equation is something like that. So hopefully you can understand how we can generate the differential equation. Now let's talk about kind of straight line. Let's talk about a kind of straight line. So well uh, well, so basically equation of straight line is what, y is equals to mx plus c. In that case, c is also a kind of arbitrary constant, and m is also an arbitrary constant. Now the thing is, let me differentiate y with respect to x. This is dy by dx is equals to m into 1 plus c will become 0, because differentiation of a constant is 0. So this will be m. Now in that case, again you can see that m we can't actually replace, right? We can't we can't actually say that m will become 0 sms for c. So what is that? Sometimes some head is coming to my mobile, I don't know why, but ignore. So basically, in that case you can see that m can be replaced here, like this is y minus c divided by x, right? M is equals to that. So you can say that dy by dx is equals to y minus c divided by x, right? And this is the differential equation for a straight line. Hopefully you can understand. Now what we can talk about, we can talk about a kind of circle. So this is, let's say, circle. So the equation of circle is what? I'm not talking about the general equation. Actually, in general equation, you will say like x minus alpha whole square and y minus beta whole square actually. But however, in that case, you can see, wait a moment. Now basically in that case, if you are differentiating, then you will see the differentiation of x square is 2x and differentiation of y square is 2y into dy by dx, and differentiation of the c, which is nothing but the radius which is fixed for a particular circle, and c is the arbitrary constant, it will become 0, right? It will become 0. Very nice. In that case you will see that like dy by dx is equals to minus 2x divided by 2y, right? 2x, I'm taking the 2x at the right side, it will become minus 2x divided by 2y. So this will be minus x by y, and this is dy by dx. Now hopefully it is visible to you, and this is the equation, I mean the differential equation for a circle. Hopefully you can understand. If you can't replace, in that case you have to differentiate it two times. Like some of the people say like in that case, if we are differentiating it for the second time, we will get d y double prime is equals to 0, which is not the differential equation. This is a rule. If you can replace after differentiating it for the first time, then you should replace. If you can't, then you should go through the second differentiation, and if you can't again, then you go through the third differentiation. However, so now it is about now uh, now let's talk about hyperbola. Now there are two kinds of hyperbola. First of all, uh, wait a moment, this is the rectangular hyperbola and this is the normal hyperbola. In that case, the you know kind of asymptotes are this x-axis and this y-axis, right? In that case the equation will be something like x into y is equals to c. You know the Boyle's law, p versus 1 by v. In that case the graph is something like very same. So however, x y is equals to c. Now in that case the asymptotes are, y is equals to minus b by a into x and y is equals to plus b divided by a into x. These are the asymptotes in that case. However, so in that case the equation will be something like x square by a square minus y square by b square is equals to 1, right? So let me talk about the first case. In that case, if we are differentiating it with respect to y, then we have to apply the uv rule, u into v actually. So taking x, this is dy by dx, plus taking y, we will get y is equals to 0, and we will get that dy by dx is equals to actually minus y divided by x, right? This is the differential equation. Hopefully my calculation is correct, I don't know, so please check it. However, and this is the differential equation for this parabola, this rectangular parabola. Now let me talk about this. In that case, let me differentiate it again. So now first of all, if we are differentiating it, then it will be like 2x divided by a square minus 2 divided by b square into y into dy by dx. Very nice. Is equals to what? 0. Now dy by dx is what? Dy by dx is equals to 2x by a square into b square divided by, this is 2y, right? I'm taking the 2x by a square part at the right side. Minus minus will be cancelled out and something like that will uh, happen. So however, in that case 2 will be cancelled out and this is dy by dx is equals to what? X b square by a square into y. Now some people might say like in that case we can differentiate it two times, but nothing will happen. Nothing will happen, be careful. Nothing will happen. So this is the differential equation for this parabola. Now some genius will say the asymptotes are something like that, so we can manipulate the a and b. If we are multiplying this, we can multiply, this will be like y square is equals to what? Minus b square by a square into x square. So we can easily replace the b square by a square term, right? But wait a moment. Why? Why you should wait? Because this asymptotes and this equation are different. Asymptotes are a kind of equation or a kind of straight line which can define a kind of graph where the graph is touching, not touching actually, approaching the infinity. It is used for understanding the behavior of the graph at infinity. Asymptotes are nothing like we can use it for understanding the equations. You can understand the equation, but if you are approaching infinity, so in infinity, if we are talking about infinite graph, in that case we can replace, but for a general case we can't. So this is the equation for this parabola and this is the equation of this parabola. And at the starting of the video I have told you, if you can replace then it's okay, then you should replace, and if you can't then you should go through the second derivative, third derivative, and if you can't again then you should not, because this is the general case. So if you can understand what I mean, basically like in multiple cases you have to replace, but in that case you can't. So hopefully you can understand how we can generate a kind of differential equation. So however, this is all about today's video. In the next video I will start solving some differential equations. I will start with the variable separable method, which is one of the easiest method in differential equations. So keep learning and thank you. Goodbye.